Hello, everyone. Welcome to Introduction to Chameleon webinar. Today's speaker, Mauricio Tavares, is a Linux and Network System Administrator at the Renaissance Computing Institute at the University of North Carolina at Chapel Hill. He is currently involved with Chameleon Cloud and Enter, enabling network research and the evolution of a next-generation mid-scale research infrastructure. Today's tutorial describes how to use the Chameleon Cloud testbed to perform computer science experimentation. It showcases Chameleon's fully customizable and accessible collection of computation, storage, and networking resources. The tutorial walks through the computer science experimental process and provides hands-on experience when making a hardware reservation and running a pre-designed experiment on Chameleon. It will last about 45 minutes with time for questions at the end. During the presentation, please type general questions in the Q&A box. Paul Ruth, one of our principal investigators for Chameleon and the networking lead, is joined by a few other team members from Chameleon who are on the webinar and will be answering your questions. Thank you and welcome, Mauricio.
Hello. So our presentation today is going to be divided in two parts. The first one, we're going to be giving a quick overview on what Chameleon is, and after that, we're going to be running a simple experiment to show how to do so. Okay, Chameleon is really can be seen as a computer science testbed in the cloud. If you think of Amazon AWS or Azure, that you can provide virtual machines and application servers. Chameleon is slightly different because we primarily offer an entire bare metal server, as in you have a bunch of computers that you can configure them using a web interface, define how you want them to be connected to and which features you want them to provide, and build a lab to make your experiments using that. So you can see that we have a bunch of different. Let's show you first what kind of equipment Chameleon has. If you go to the website, and you hit the hardware tab and wait a little bit, we can see that Chameleon provides FPGAs, GPUs, some low power Xeons, Atoms, ARM, x64 CPUs, such as Skylake and Haswell, storage and InfiniBand. Now we go back here. So Chameleon is powered by OpenStack, which is a open source cloud solution. And the Chameleon team actually not only supports OpenStack, but contributes back to it. So Chameleon started with the Haswell CPUs and some GPUs, FPGAs, and other devices connected to 100 gigabit uplink in two different locations at the Texas Advanced Computing Center in Austin and the Computation Institute at the University of Chicago. Later on, they also were joined by the Northwestern University in Chicago. In 2017, the Skylake CPUs were added and Corsa switches, which allows you to do NetFlow. So today we're going to be running our experiment, and to use Chameleon, you need to have a Chameleon account, which also you would require a project membership. If you don't have both, you cannot run Chameleon. Then you need to have a SSH client. which can be on Windows, Mac, Linux, on your phone, whatever. It just have to have an SSH client and SSH keys. If you don't have SSH keys, don't worry, because later on I'm going to show how to use Chameleon to create your SSH keys. If you do not have your Chameleon account, you might want right now to click on the Q&A button and see if you can ask for someone to help you with that. But you'll be advised that it can take 15 to 30 minutes to get that up. In the meantime, what you can do, you can just follow along the presentation. And if you go back to the Chameleon website, you can click here on documentation, and you click here on the button Get Started, because this presentation is kind of similar to this documentation here, Get Started. So if you miss something here, just go back to this documentation, follow it along, and the slides are going to be available later. So you can, once you follow the instructions here, you can go back to the slides and repeat the same experiment we had today. So now, okay, the experiment workflow looks something like this. First of all, you need to design your experiment, figure out how you want to do it. And then after that, you need to figure out what kind of resources you're going to need to create your experiment. We're talking about, creating a virtual lab. And then after that, you need to reserve the resources. We are going to be talking more about that later, but the idea is some of the resources are very popular, so you need to reserve them well in advance of actually running them. After that, we are going to, you have to configure those resources the way you want and how you're going to access them so you can upload your data. Then you're going to run your experiment, monitor just for any error codes, and then you get the output, you analyze, and then you can decide if you want to use, if you're satisfied with the results, or you need to modify your experiment and then do it all over again. If you're satisfied with your work, you really need to tear down your experiment, because other people might want to use those resources later. So let's talk about discovering the resources. It's that same page we saw before. So we can go back here again. And here's an example. Let's say that you want to use some GPUs. By just clicking here on the GPUs, you're going to find out they are only available in the Texas site. And there's on the Intel 64-bit CPUs, and it's going to be machines. Each of those machines has 2 CPUs, and some has 48 threads and another 56 threads. Now let's see how do they look like. Okay. So this is one of those, this actual information about one of those physical machines. You see it's running on Intel PowerEdge R730. The GPU model is a M40, NVIDIA. You can see some more information about each specific machine. And there's a lot of them. And we can go back to here. So you might want to use this page to figure out first of the available resource, which ones you want to use and where they are. Once you have that, you want to reserve those resources. To do so, you're going to actually have to log in to using your Chameleon account. And then we wait. Okay, once you log in, you want to go here and click on experiment, and then bare metal site. You should see a screen that looks like this. On Chameleon and OpenStack lingo, instance is actually a computer, a node. Since you're using bare metal, is a physical server somewhere. Image is the operating system with sometimes as a bare operating system or some customization. And right now we want to talk about the reservations. So you're leasing as if you would be leasing renting a car. And let's show you some of the, yes, you have one of my leases. Okay. Just shows how, the lease, how all the resources that are currently in use in Chameleon. Let's say, for instance, you would like to make your experiment running those GPUs. As you can see, let's try the 30th. And you can see that most those are in use at least until the end of the month. So if you want to use those GPUs, you probably want to start them, say, somewhere in July. You see it's still currently open, so you'd like to reserve something here. But in our case, we're going to be running we're going to create a lease, and we're going to be using those Haswell computers with nothing else. They are the older 64-bit CPUs, so they are usually available. So that's why we're not going to worry about setting up a start date and start time and the end date. So we're going just to create it, a lease, and I'm going to call that like that. And then we're going to wait for it to create it. And it looks very exciting.
But let me know to ask questions again if you want.
Okay, yeah, while we're waiting here, if you have any questions, please click the Q&A button, and we can be answering while you're waiting for for the list to be available. Because right now the list I create is on pending state. I have to wait until the list is in active state before we continue. So. Okay, let me just refresh the page and see if it's, okay. We are active. So the other thing we want to do right now is, if you, we want to, we've been here, and sometimes this page sometimes might be part of more than one project, and you want to select whatever project you want to run your lab on. On my case, I'm just part of just one project here, so I don't have to select anything. So quick leads and stuff like that. Now we are going to configure the node. So first thing we're going to do, we are going to create a key pair. There are two ways to create a key pair. If you know how to create a key pair on Linux or whatever other operating system you want, you're going to click this button and you're going to import here the public key. You're going to give it a name, import, and off you go. You can just paste the key here or just look for your file. But in this case, we're going to let Chameleon create a key pair for us. I'm going to call it the key. And say create the key pair. And then as you see this dialog box saying opening the key.pm, that's your private key. You need to save that to your local computer. And now let's see if we find the key. There's the key. This is how the key looks like. Nothing special to it. So now that you create the key, the next step is to create the instance. And we can probably go back to the slides. So we create key pairs. One way we can create the instance, easy way to create the instance is if you go back to the Chameleon Cloud page and hit Appliances. Appliances are already pre-configured images that you can use for your Chameleon lab. One thing I want to show you is that if you look this little icon here, it says Chameleon official image. What that means is the Chameleon team created this image and made it available. That also means that the Chameleon team is making sure that this image is kept updated, and if it has any issues, those issues are solved. This one doesn't have that, so it means somebody else created it and made it available here in the appliance catalog. Another interesting icon that you want to be aware of is this one. This one, as it says here, is a complex appliance. What that means is that it's created not just one machine, but could be more than one machine put together with some network between them already pre-configured. For instance, in this case that I'm just here, is a base complex appliance deploying an NFS server with one client. So you have at least two machines here, the server and the client, and they're configured to do NFS, and there's a connection between them. For this lab, we're going to pick one of the simplest ones, the CentOS OS 7 default Chameleon appliance. So just click on it, and you're going to be launching it at the Austin system here. So there it is. And this is a bare metal image. And you're going to, and also if you want, you can go to GitHub and take a look at it if you want to play with it on your own. Now we hit launch. Now we need to give a name for our server or instance or node. So keeping my trend, I'm going to call it after my account name and just tell it's a server or server one. Reservation is our lease. This is the lease I created to use this. Now, source, that's the image we selected using the web page. Flavor, we just have one here, which is bare metal. Networks. For Chameleon, you want to use the shared net option. And the key pair, you want to use the key pair you selected. As you can see, I have 3 key pairs, but the one we are going to use, the one we created earlier, the key. And then you click on that, and now you're going to launch the instance. And then say, okay, success, instance created. Now, if you click on instance, you're going to see this exciting animation of the instance being created and built. That's going to take around 10 minutes. So you might want to use this break for us to, if you have any questions, we can wait, and you can click again the question and answer button, and we can help you out in the meantime.
You can give them like a tour of the rest of the stuff if no one else asks questions too.
Okay.
Some of them, they're asking questions about heat templates. So maybe go, if you wanted to give more, if you go to like the complex appliances, and you can kind of like show one of them. I don't know if you know that much about them, but I can.
No, I haven't. Do you want to just go?
Yeah,
over?
I can do that here.
Yes.
Yeah, I'm Paul Ruth. I'm the PI here for the networking portion of Chameleon. I'm also sitting in here answering questions to some people, but since we have 10 minutes to wait, and there was some questions about heat templates or complex appliances, I was going to show you a couple things. So who was it? It was Kevin Bahani was asking questions about this. So what we have here, if you want to start him, the question was about if you wanted to deploy a Docker on a lot of nodes on Chameleon and put a lot of Docker nodes out there. So what we have here under appliances on Chameleon, these are all sort of templates that some of them the Chameleon team manages, and other ones are managed by just users that have built them and sort of donated them back to us. And some of them are these complex appliances. They have this little tab in the corner here, and some of them are basically just virtual machine or bare metal machine images that you can use. So what's interesting here, if I find one, I think there's a Docker one. I might use that because someone was asking. Isn't there a Docker one? Maybe there's not a Docker one. Maybe there's not a Docker one. I thought there was a Docker one. I know there's a Docker image somewhere. So what these can do, I think the Hadoop one's a pretty easy one. So this one is actually a template that'll deploy an entire Hadoop cluster all in one go. If you click on the appliance here in the appliance catalog, you get a little description. Click on documentation. There's sort of a documentation about how to use it. It's a little beyond this particular tutorial to do this, but just know that they're here. If you look carefully here at the template, it wants to save it and not open it.
You can hit open and see if you can then choose a program.
Usually it just opens it on my machine. It just opens.
No, because you selected it. So
yeah.
Scroll down here. You might have something to open. Like the
text
go up.
Text
Yes.
it'll do it.
Yeah.
Boom. All right. Here you go. If you see here, probably Command Shift plus whatever. I don't want to log it.
Might have to select everything and then
Zoom in. Oh, that's a lot, but it's all right. So if you look here, what this is just a template that describes the. It's a heat template. That's heat is the OpenStack. I don't know what you call it. The piece of OpenStack that does these templates. Inside the template, you kind of define different resources, and this is a subnet, so it's a network piece of the network. It's the network itself. There's a router. There's an IP address, and we'll talk about that a little bit later. Here's a group of workers and all their parameters, including a template that will be run, or a script that'll be run once the node is booted. And in this case, it installs Hadoop.
it looks very like Puppet.
Yeah. And then there's a Hadoop master node and, some various other things. So if you want to run some complex Docker things, you can create one of these heat templates, and you should be able to just template it all, and it'll all just start by itself. And you can push go get some coffee, and come back, and it's done. That kind of thing. Let's go check and see if the node's booted.
Yeah.
Let me see if there's any more questions.
It's still spawning. think now I can, one thing we can do while we're waiting, we can associate what is called a floating IP. The idea here is, if you think of your home network has an internal network range, but for you to go outside, you need to have an external IP associated with it. Especially, this is kind of important, especially that, not only for you to go out, but also if you want to go back in. And in my own case, I tend to remote into my home machine, so I need to make sure that I know what's my external IP. That's what the idea for the floating IP here. You can select an external IP and associate it with one of your servers, so you can connect into your, you can remote log into your lab and continue working on it. Since we just have one server, I'm just connecting to it. Now, if you go back here to instance, we're going to see that that was the internal IP, and this is the external IP. So once this machine is ready for us to connect, to log in, we are going to log into this machine from the external IP. This server, of course, doesn't know about this IP, and we're going to see that once we are able to log in. But meanwhile, we're still waiting.
It should take 8 minutes, pretty much exactly.
Okay. If anybody still have questions, we still have time.
Is anybody actively trying to get nodes to running right now and having problems with it? If so, ask a question and we can maybe get you going. I'd be very surprised if everyone was trying to do it and being completely successful. That doesn't happen.
Could you check to see if under your group?
Yeah, I'm gonna check. I'll check mine.
So, well, while we're waiting, some other useful documentation here is, we have the getting started, but after that, you want to probably take a look at this. Describes about how you provision and how you do your reservations. The resource discovery we talked about. Here goes a bit more detail. Bare metal instance. And image and how you create it, how you manage. And we're going to even has how to use FPGAs and Chameleon. And yes, there is Chameleon does have virtual machines, but that's not what we are. Our main business. Our main business is able to create you a virtual lab with physical machines that you can do whatever you want. And okay, it says it's running. Let's find out what does that mean, because that could just mean the machine the server is running, but it doesn't. We cannot connect to it just yet. Let's start by seeing if we can ping it. Okay, so the computer is up, but we cannot reach it just yet.
Why can't you reach it?
Hmm?
Why can't you reach it?
Well, because the network interface is not available.
Yeah. Tell them what's happening. Yeah.
Okay, now we're pinging back, so the entire interface from the server to the external IP and then to the outside world is up and running. Now the next step is, since if remember we're going to SSH into the machine, so is SSH up and running? Let's find out. Okay, it's up and running. So now let's try to connect. We're going to use the key. So SSH minus I, we're going to be providing the private key. And I'm going to try to maybe connect like that. And it's not working. Oh. Offending key. Okay. I don't care. So, okay. Let me get to read because I think I connect to that IP already. Yep. So let me clean this guy. Now let's try again. Okay, looks promising. And I wasn't able to connect. Bad permissions. What does that mean? If you look at the permissions for my key, everyone can read and write to it. So I need to change the permissions so that only I can read or read and write. So you can do chmod any way you want. You can say just like user or group another and delete that, or you can just use the numbers. So 600, that should be good enough. And so now only I can read and write. And if you know in Linux, that would be your group and that would be others, the third one here. So let's try to log in to SSH again. Okay. It doesn't like me to SSH as root, so it wants me SSH as the user. CC. Here we are. So we are on our computer. As you see, we have a lot of space here, 8 terabytes to play with. Now let's see what else we are going to be doing to this machine. SSH, we did that. Now we need to do some experimenting. Okay, our experiment, we're going to be doing some, we're going to be running something to generate some load and monitoring it. If you want to see about how you do some monitoring, getting some metrics, if you go back to our documentation and click on the page here, monitoring, you're going to see some information about how to do that. So let's go back to, so here we're going to be using the OpenStack client, which is already installed in this image, so we don't have to install, but if you're running a different image, you need to install it. This is the command you would use to install it. So another thing you need here to do, we need to download a script that you configure your account on the machine the server we just created, so you can run OpenStack commands. Let me show you how to do that. We go back here. We download this file, which is downloaded locally. And after that, I'm going to get out of the server we created just for a little bit. if you look, just the file that we download is called ch something. And you see this and that was customized for your account. So you cannot use mine, you have to go and download yours. And then after that, you can, if we're going to have to copy it to, there are two ways to copy that. One is you can just cut and paste, or you can just use SCP. Last time I used SCP, but this time I'm going to use cut and paste. Just because. So we're going to SSH back to the machine. And API something like that. We're going to paste it. And then you can do a source like that. You see now it's asking for, it knows that your Chameleon account user is what it is, because remember we download from the account, but now it needs your Chameleon password. So there it is. Now let's check to see if this works. OpenStack server list. If that works, should give a list of the servers that we have. Okay. So you can see it's showing here some stuff. Also, we can see here the name of my service is that it's active. We know that. The internal network IP is this, the external IP is that, and you're running this image, and it's a bare metal server. Okay, so far so good. So now we need to get the instance UID. We are going to need to use it later. Some ways we can use that is we can go back to here. If you click on this guy, that is the instance ID it's looking for. Another way to do it is you copy this curl thing and run it, you're going to get it back. And that is, but I already just copied from the GUI, I'm going to use that. So now we are going to run this command here, OpenStack matrix resource show, and use the instance ID we just grabbed. So let's do it. OpenStack matrix resource show. Okay, this is the list of all the resources available, and the things we really care about for this lab are the metrics. Some are here show interfaces, information about all the different interfaces we have, including loopback. The load one here is for CPU load, and you have memory. Let's take a look at the CPU one. So we're going to run this command here. Instance ID is this thing here. So we're going to get to resource. Measures, show. We want to use that. And
that one's left.
resource ID. Yeah. I can type. Let's make sure I know what to command. Okay, I need that little, those 2 dashes here. Let's do it again. There we are. What's this showing you is in a theoretically in an interval here, like every second, but really it's going to be 10 seconds. That's 60 seconds, 1 minute, or 60 minutes. And then it's giving the average of your load, and the units are pretty much the same as here. So now let's go to now we're going to install this program here in Stress to do some to load the CPU, make it work, and then we are going to see how the output for the program changes if X is going to report the CPU load increasing. So let's go back to here and download it. Yeah, minus Y, so it doesn't ask me. If I really want to do that, install Stress. Okay. Finish installing, install done. Now we're going to run sudo stress CPU 16, so it runs, use all the CPUs, minus timeout 60, and which is going to run for 1 minute. I'm throwing it on the background so we can see what happens. As you notice, it starts increasing the load, or reporting the load has increased, but it's not as real time as you think. So it's, in fact, if you see it already finished. Okay. Okay, finally we start getting some. You saw how long it took for it to start pulling the data out of the database where it's storing this metrics. So let's see how long. Okay, actually run twice. 42. Maybe I'm too impatient. But okay, eventually this is going to go back to the 0.05 to 5% here. And that would be pretty much the experiment. And okay. Okay, finally it went up. So it's still if you go to uptime, you'll see, yes, it's still the low CPU is high, or went all the way to 6 point. So it captures, maybe not. Okay, well, I think you got the idea. So final step here. I'm going to let just run a bit and ignore it until it comes back. But usually the last step you do here is you go back here to your list of instances.
Don't delete it yet, though. Okay,
No, I'm not going to kill it just yet.
We could ask some. There's some question too I want to ask.
Okay, and then you can hit here and then say delete instance. So still doing its thing. Yep, start coming down.
If you want to answer sort of one of these questions, something be interesting, type ls really on your node. I
Okay.
just want to make sure this is one of the ones that does it. Okay. Yeah, so I'm just gonna interrupt a little bit and answer a question that we got. So somebody was asking, I think it was Kevin, and was asking a question about snapshotting nodes to like temporarily save data so that you can restart them again. So you can do that, and that's what I wrote in the answer, is that you can do that, but it takes a long time to completely snapshot a node, and it also takes a lot of space on all of our servers. So there's some groups that do this a lot, and they just take a lot of space. We have to work with them to delete some of their older stuff. But what we have set up here, Mauricio has shown, if you use one of the standard images that we provide, so most of them are either our standard image or based on that. I mean, there's crazy users that build whatever they want, and there's no guarantees that their stuff's going to work for you. But if you use like a regular Ubuntu image or a CentOS image, it should mount this folder here called My Mounting Point. So here, to go into My Mounting Point, you might not even have anything in there. Just type ls in there. So this is because it's in my project, right? So what you'll get in there is this will maybe do like a df -h or something. You can see, so you can see that that mounting point that's going to be in all of your machines, and you can see that it has lots of space in it. It's actually a network storage that's just for you and for your project, in fact. And what Mauricio just did is he went into that directory and he saw a bunch of files that were actually from some stuff I was doing before. And what you can do is you can copy all of your data into this directory, this folder, and it'll be there for the next time you create another node using the same project. So that's a good way to do that if you want that.
One thing also we should talk about is how long you can run a lease.
Yeah.
So I think you can run what, a week?
Well, 1 week. So you can create a lease that's a 1 week long lease. And at the end of that lease, you can in fact extend the lease further, provided that there's no one that's
using those resources.
Reserved it in front of you. And I'd say for most resources, like regular Haswell nodes and Skylake nodes, you'd probably be fine to be able to extend them for quite a while. If you want to use like GPUs especially, you're probably not going to be able to extend them because people use them a lot. But yeah, I wouldn't worry too much about that. You do, however, in your project, you get an allocation of time on the test bed. And if you have reservations that exist and you're not actually using the nodes during those reservations, it's still charging your account for the time that you're using them. So you want to maximize the use of your allocation. So you don't want to have reservations that aren't being used. Otherwise you'll run out.
Which all goes back about planning your lab.
Yeah.
Planning your lab, scheduling in advance, and going from there. So let's see if this guy's finally came back. We're just stalling. Okay, it's slowly coming back. And eventually went back to the 0.05.
Yeah. So should we open it up to that? We did that last time where anyone could raise their hands and talk and stuff like that.
Might as well.
Yeah.
And
so what we've done in the past is we've how do you do that? There's a button that says raise your hand.
Oh, I think that's actually in chat. We have disabled. But if somebody wants to put their in the Q&A, then I can let them talk.
Yeah. So if you want to ask a question live, like with your voice, and if you put a question in the chat, we can unmute you and allow you to talk, and then we can answer whatever question you have. And we can be here for a little bit longer than the end of the hour if needed. Or if you can see the button that says raise your hand. I thought like we can't see it from our view right now. We're not exactly sure.
Yeah.
I don't know if people are just typing and they're not. Yeah, if you just want to, if anyone wants to ask a question, just say, "Let me talk," and then we'll unmute you.
All right. Well, thank you, Mauricio, for presenting this talk today. We appreciate your time and that of our attendees. Please make sure to join us in 4 weeks for our next webinar, Experiments Spanning Chameleon and Genie, and that will be on July 16th. So thank you all and have a wonderful rest of the day.